Hello, good afternoon. Well, first of all, I'm Francisco Rios Chavez. This is the evidence number 3 from the Unit 1 of Manufacturing Process, and my professor is the engineer Paulo Garcia. Well, the work that I'm going to present you, it's about developing a presentation performance record of the analysis of a real system through a home video clip to determine the inputs, outputs, and feedback of the system. The video at least has to last 12 minutes, also has to show inputs, outputs, and feedback of the system, and for last but not least, it has to have 6 images or more. The system that I am going to present you is the water cycle, also known as the hydraulical cycle. I will describe the continuous movement of the water on Earth. It encompasses various stages, including evaporation, condensation, precipitation, and runoff, all working together harmoniously to maintain the delicate balance of our planet's ecosystems. Our journey begins with evaporation, where the sun's radiant energy transforms water from ocean lakes and rivers into a water vapor, as you can see in the image. As the water molecules gain energy, they break free from the liquid state and rise into the atmosphere. Once in the atmosphere, the water vapor cools and condensates into tiny water droplets, forming clouds. This process occurs as the warm air arrives carrying the moisture with it. The transformation from vapor to liquid is a crucial step in the water cycle. Next comes precipitation, the stage we are most familiar with, when the condensation reaches a point where the air can no longer hold the water droplets. They fall back to the air's surface as rain. Also, there are more types of precipitation like snow, sleet, hail, and graupel. Precipitation renews our water sources, replacing rivers, lakes, and groundwater. Following precipitation, a portion of the water seeps into the ground. This process is called infiltration. It percolates through the soil, eventually reaching the water table, which is the underground reserve of water. This stored water, known as the groundwater, becomes a vital resource for drinking water and sustain various ecosystems. However, not all precipitation infiltrates the ground. Excess water unable to penetrate the soil or be absorbed by plants become runoff. It flows over the land, collecting in streams, rivers, and eventually merging into large bodies of water like lakes or the ocean. Runoff plays a crucial role in transporting nutrients and sediments, shaping landscapes, and supporting aquatic ecosystems. Now let's shift our focus to the role of plants in the water cycle. Through a process known as transpiration, plants absorb water from the soil through their roots. This water then travels up to the stem and eventually evaporates through tiny openings in their leaves called stomata, releasing water vapor back into the atmosphere. As we can see, the water cycle is a beautiful interconnected process. It has no boundaries, transcending geographic borders and connecting all regions of our planet. It links the atmosphere, land, and oceans, influences water patterns, climates, and the distribution of water resources. Understanding the water cycle significance is crucial for several reasons. Firstly, it sustains ecosystems, ensuring the survival of diverse plants and animal species. Additionally, it supports agriculture, providing water for crops and livestock. Moreover, the water cycle is essential for human life, supplying us with drinking water and powering electricity. However, the water cycle faces various challenges in the modern world. Climate change, pollution, and overuse of water resources pose significant threats. It is our responsibility to protect and conserve this precious resource, ensuring its availability for generations to come. Well, now I'm going to explain where are the inputs, the processes, and the outputs. Well, for me, in this system, inputs, processes, and outputs are everywhere. You will wonder why. Because in each step of what I explain of the system, there is an input, a process, and a output. Let's say, for example, the first step. Here in the first step, the input it's the raw material like the water and the sun energy could be. So here the process is that the water molecules gain energy, they break free from the liquid state and release into the atmosphere. That could be the process, and the output here is the condensation. And now here in the condensation, the tiny water droplets could be the raw material like the input, and the process could be that when the condensation reaches a point where the air cannot longer hold the water droplets, they fall back to the earth surface as rain. That will be the process, and the rain, the water, now is the output here. And for now on, for infiltration, runoff, and transpiration, here the raw material is the water, and the processes are all the things that the water do, like in infiltration, it's it's it percolates through the soil, eventually reaching the water table, which is the underground reserves. That could be the process in infiltration, and the output it will be the service that give us the water. Because of that, now it's now the water becomes uh, drinking water. And for transpiration, the water is the raw material. That means that is the input, and the process here is that the plants absorb water from the soil through their roots, and this water then travels up to the stem and eventually evaporates to tiny opening in their leaves called stomach relation water vapor. and that's the process. And the output now here will be that the water became vapor again. But in general, the system, it starts in the evaporation, and that and for the evaporation, the raw material, like I said before, it's the water and the sun energy, and the process, it's from all that the water pass, like the condensation, precipitation, and infiltration, etc. And that will be the process, but the outputs will be like the service that the water gave us, that helps like the plants, another another ecosystems, and human life. For me, those are the inputs, outputs, and processes. And for feedback, I think that the water ecosystem doesn't need to change nothing because everything is balanced. And that's all. I hope you like it, and thank you for watching.